Good afternoon, folks. Paul, nice to see you.
You too, Gord. Thank you for having me.
This is
So
kind of a
real
cool
quick,
opportunity.
yeah, just want to say welcome to the webinar to everyone. For those of you who don't know me, my name is Paul Springer. I'm the National Director for AeroBarrier, and the man beside me obviously doesn't need much introduction. Obviously, you know Gord Cooke. Today we're going to be talking about air sealing. Historically, this has been a very inefficient and a process that in some ways hasn't really been focused on. It's something that got done through the process, but maybe not done well, and there's typically a lot of trades that are involved in the process. So looking at ways to improve that, and construction in general hasn't changed a lot over the last 10 years, and we're seeing codes and building performance standards change, and air sealing is really starting to come into the spotlight as one of the key foundational principles to not only meeting code and certifications, but building a strong foundation and a high-performing home that we care about and that'll last for generations. So we're going to spend a lot of time today talking about air sealing and the importance of it, and not just the importance of it, but how to do it better than we've done historically, and how to streamline that process for builders to not only save time and money, but just make it a more streamlined process in general. And I know I'm going to hand it over to Gord here shortly. We have a lot to cover today. If you have questions, please feel free to throw them in the chat. We will be recording the session today for future reference and for anybody that may not have been able to join us today. So if you have questions, please feel free to throw it in the chat as we go, and we'll answer them as we get to them. And I'll go ahead and hand it over to Gord for a quick introduction.
Thanks very much, Paul. And that burden, if you're going to be recording it, that means any questions people have to be really intelligent questions. Is that right?
Yeah, of course.
But thank you, Paul. Very pleased to be here. Gord Cooke, Construction Instruction, one of the principals. I'm coming to you actually from near Toronto, Canada, Cambridge, Ontario. Wish I could be with you guys more in person, but we're very pleased to help with these education webinars. And you say that pretty interesting, Paul. You said hasn't changed much in the last 10 years, but of course my experience is more like 30, 35 years. I still see the same methods, the same materials trying to be used to make houses airtight, and yet the huge angst, and you'll hear me say that word a lot today, the angst that builders and trades and so on have. And it does present a huge opportunity. We all know when there's angst in the world, that's an opportunity for some to take up on that. It's one of the things I want to make sure people on the call recognize is that the AeroBarrier technology is a huge opportunity that, Paul, you will know I've seen just, in full disclosure here in Canada. I actually brought the technology to Canada, a partner of mine, and in fact, my son are running that business, and we've found it just to be really, really powerful. So I'll state that up front. I'll probably tell you again during the session that, I clearly am sold on this technology, but I think the reason I'm sold on it is because I think it solves a lot of problems for the building industry, and we'll get onto that. And so we'll put up the slides. I have probably way too many slides, but Paul, I'll ask you to stay engaged, and we'll ask you to pipe in as necessary. So joint session brought to you by Construction Instruction and AeroBarrier. As we move through, I'll just chat briefly, just remind you, it's three partners, Mark, and now we have a CI Live Center that we would say start coming to Denver. We're opening up as of October to have in-person live training sessions in Denver. So really hope to get to see you guys shortly. For those who aren't familiar with construction instruction, please download the app. It's a free building science app. AeroBarrier's on there, sponsored by or partnered with a number of manufacturers, but we're very proud of the animations that we've put together that help builders solve problems in houses is where we'd like to get to. And in terms of today's agenda, kind of what was promised to you on the promo for this piece, we do want to talk about, what is an AeroBarrier? What are the layers of an AeroBarrier? Some of the methods around that. Most of that's going to be pretty familiar to you guys, but I just want to give you a sense of, just so you know, we're all on the same page as to the kinds of methods, material, good solutions, doing a nice job of that. But we of course want to talk about the inefficiencies of some of those methodologies. And then really, Paul, you and I are going to get to give an overview for those who haven't seen it hopefully they have, but a little overview of the technology that you are involved with, that you're so committed to, and as am I. And we'll show just a couple of quick examples from results from some great builders across the country. And the last piece is thinking about this as a business opportunity for some of you on this call to say, I wonder if this is a technology that I should be helping my local building community with. So that's kind of our agenda for today. There we go. I thought it might be useful to start with the definition, and there's a number of definitions out there, but let's go straight to the code. The International Residential Residential Code would say an air barrier is one or more materials. That's an interesting concept in itself. One or more materials joined together in a continuous manner. Oh, that's a key phrase. To restrict or prevent the passage of air through the building thermal envelope and its assemblies. If we tore apart that phrase, opportunities, one or more materials, risks, continuous. What does the word continuous mean? You guys may or may not know this on this call, but in the province of Ontario, about 60,000 houses a year, every one of them covered by a mandatory new home warranty program. That word continuous to a homeowner, or more importantly to the lawyer of a homeowner, means what? Exactly how many holes would that mean in your building enclosure? And you'll hear me use that phrase a number of times. So that's the definition of air barrier in the code. And then the code goes on to say in a series of, in a table, it starts to lay out for you. And Travis, you could just click through to, there's a number of pieces on this slide. If you could just click through that. Yes, thank you. These words, thank you, stop there. There are 17 separate references to the word sealed and continuous in the code. And again, I'm just invoking for you, I'm saying to you, a local building official, jurisdiction having authority, or a building inspector for a homeowner. These words, what do they mean to them, and whose scope of work do you put this in now? Who is responsible for this word continuous or sealed in your build? So you need to have an appreciation for this has been in the code since at least 2009. In fact, air barriers were mentioned in the very first IECC, International Energy Conservation Code, in 1997. This language has been there since at least 2009. And when we think about an air barrier, the first thing to say when it says a combination of materials, what kind of materials are we talking about? There is a material standard, an ASTM standard 2178, that will test things like drywall and plywood and OSB and house wraps like Tyvek and foam products. That's a material testing standard. So in order to qualify as an air barrier, you would need to at least show that your material, that your primary air barrier met these requirements. You're going to find that just about every material known to man meets those requirements, except fluffy insulation, for example. Actually, some water-resistant barriers are not qualified as air barriers. Some of them are perforated, little micro perforations, and they're not considered air barriers. But many, many building materials that we commonly use are indeed air barriers. The codes are starting to go a step further and saying, okay, the material itself may be airtight, but what about when I put holes in it, penetrations in it? That's a new level of test called assembly test, which is ASTM 2357, where they actually have you ship a wall panel, two different wall panels actually, with different penetrations in them, and they actually test the entire panel and tell you whether it meets that assembly test. What we're seeing, of course, more and more of is whole building testing. And you'll notice that each of these are kind of an order of magnitude apart. That is, you don't expect the whole house to be the same air tightness as the building might be. It's actually two orders of magnitude as tight as the material itself. You don't expect that. So the materials themselves have to be much tighter than the assembly, and the assembly in turn has to be tighter than the whole building. But let's get to whole building testing. As many of you know, that's where the code is driving. We could really care less about the material. What we want to know is, in situ, how do I make sure that it meets air tightness requirements? And so what's powerful to understand is that collection of materials, we get to say it can be either on the exterior or on the interior, or it can be a combination of both interior and exterior. And we'll walk through some choices here as we move through this. Yep, sorry. So on the interior side, what would qualify? Well, drywall is defined as an air barrier. Poly vapor barriers are defined as air barriers. Spray foam would meet qualifications, as would poured concrete. On the exterior side, things like OSB and plywood, coated or not. There's some coated plywoods out there, and OSB, sorry. But even untreated OSBs themselves qualify as air barriers. Foam sheathing, gypsum sheathing, poured concrete again, weather-resistant barriers, at least water-resistant barriers. Many of them do, some don't. And roof membranes would all qualify as air barriers. The issue is the word continuous, right? How do I make them continuous is what we want to think about. And so your task is to decide what is the primary air barrier. In code, it asks you to think about the primary air barrier. You need to identify these materials. And in fact, get your architect to identify on the plan in each section of the house what the air barrier is. You might be using the WRB on the right-hand side. You might use the WRB as your exterior air barrier in the walls, but clearly it's got to connect to an air barrier in the ceiling or the attic. Are you going to use the roof membrane and have a conditioned attic, or are you going to use the drywall in the ceiling as your air barrier? You can start to see you are going to use multiple materials around the building. And I like to show this not as a joke, but basically to understand that we've always had air barriers in houses. The original air barrier in a house was those 12-inch thick log walls. But then we had to make them continuous. So what did? We stuffed them with leaves in the early days and moss, and then stucco products, chinking it was often called. And we would stuff them from the inside, we'd stuff them from the outside. Why? Because we didn't want the cold drafts, we didn't want the mice coming in the fall, we didn't want the smoke coming from wildfires. So we've always had air barriers in houses. The challenge was, how do I make them continuous based on my choices of that primary air barrier? If you can move the next slide. There we go. And we'll just play this animation, so give that yet another click. If I said to you an interior air barrier and we were using drywall as the air barrier, well, it really just means 3 or 4 beads of caulking. A bead of caulking across the top plate, a bead of caulking across the bottom plate, beads of caulking around the windows themselves, beads of caulking around the electrical outlet, and you would say, there's my air barrier. The issue, of course, is whose scope is that in? Is that in the drywall contractor? Is that scope? Is that in the insulator's scope of work? What about the electrician? What about the plumber? All the other contractors who end up impacting this air barrier. And hence, there is the challenge. Air barrier materials themselves are dead simple. You have thousands of square feet of them already on your buildings. The trick is who's responsible for the air barrier. And I got to say, builders on this call, start writing in your scopes of work. Who's responsible for air barrier details? And Paul, you're going to be able to say that's really where we want to talk about air barrier as being a tremendous opportunity, that I can take it out of the hands of those multiple trades and have it down to one trade. Is that what you're finding out in the field?
Yeah, 100%. Instead of, like you said, Gord, the drywaller, the insulation contractor, the framer, some of their scopes cover the air barrier and air sealing, some of them don't. And getting those 3 to work together can be a challenge. So having one set point or one set trade that's really responsible for driving the outcome and the performance you're looking for adds a lot of value, especially with a really simple, easy solution.
Absolutely. Thank you for that. And the next slide then. Thank you. And so when we think about detailing that interior air barrier, think about, okay, the air barrier sounds really easy, drywall, but what about intersecting walls? How am I going to frame those to make sure that I have an opportunity for an air barrier in behind that? And the left-hand side, the intersecting wall at the outside wall, or what about at the ceiling level? How do I make sure I make that continuous? And you start to imagine each one of those studs, each one of those locations, I have to think about making it airtight, especially that one on the ceiling is of interest to me. That top plate will shrink over time, or at least as when it first gets installed. It creates this tremendous air leakage. Anybody's done a blower door test, you'll feel air leakage on an interior wall, and you go, where'd that come from? Well, it came down from the attic, past that gap between the drywall and the top plate. So how do I make that continuous? Who's going to install that bead of caulking or gasketing? That's what we need to think about. And next slide. And we see a lot of folks trying a lot of different things. On the left-hand side, contractor said to me, I got this. And he used about 20 cans of expanding foam to basically picture frame every cavity. And I said, well, good try, but frankly, that's a complete waste of effort. We don't really need to think about making OSB more airtight. The only place I actually need those beads is where the OSB is not continuous, if OSB is going to be my air barrier. So we see people going over the top in terms of their efforts using frankly the wrong material, because that foam doesn't really work in that situation anyway. It needs to be injected into a hole. It doesn't really work sitting on the surface like this. The one on the right is a proprietary system. I like the product. It just, in this case, trying too hard, using the product more than it needs to be, and wasting literally hundreds, if not thousands of dollars. And similarly, people using the wrong material on the left-hand side, again, using that foam product. We know what's going to happen. The drywaller is going to come in and immediately scarf that off. And if he doesn't, then the flooring contractor is going to scarf it off. So it's the wrong material in the wrong location. So we have to think about the right trade, who's going to do it, the right material, and thinking about consistent training. The one on the right, at least they've made some nice attempts to put it in the right location, but clearly didn't understand the issue of air tightness when the bead of caulking is out in the middle of the floor, out from the edge. So we need to think about that. I don't need to be saying that we're too negative about this. I just want us to understand the challenges that it takes of getting the right trades, the right location. There on the right, again, the fact that we've used maybe the right material, that caulking, but it's not continuous, not in the right location. Travis, one more. Yep, thank you. The one on the left, the beads of caulking on those little jack studs, as if that's going to improve the air tightness of the building. So we see people spending a lot of time and effort and really not understanding what we're trying to do here. All I really need to do is picture frame where that sheet of drywall is going to be. The drywall itself is airtight. Again, the one on the right material, but not the right consistency in terms of what's happening. So this takes effort. And my experience has been, Paul, I don't think you would disagree. My experience has been, if we're not retraining about every 3 months, trade contractors, and it's not because they're bad people, it's true of any industry. But every 3 months, we need to remind them of where the beads go, the right compatibility materials. We'll see seasonal changes. Well, I don't use that in the winter because it's too cold outside, or I don't use that in rainy season because it doesn't adhere well. And all of a sudden, they're choosing the wrong material for that application. So making sure that if we're going to make a commitment to these kinds of products, that they're installed correctly is really important. And we do see some searches for some simple, consistent approaches on the left. This is in a party wall detail. They're using a product called RCL, I believe it's called, a foam gasket. Absolutely. So now that rather than putting a caulking and the the drywallers having to worry about a caulking, they simply staple up a gasket. And this is a nice way to picture frame, but simple caulking products there on the right. I'm a big fan of Quad Max, Henkel's Quad Max product, OSI's product, and absolutely looking for the right materials, trying to find those consistent approaches that can be done day after day, year after year, house after house. We need to think about. Next slide. Yep, thank you. And we see spray foam has kind of been a choice that I saw come along about 35 years ago. And did it improve the airtightness of houses? Yes. But we do need to understand, when you spray foam over top of a piece of OSB, you didn't make that OSB any more airtight. So by all means, use spray foam for thermal effectiveness, consistency of your insulation, but also imagine I still have work to do. On the right-hand side, I still need to put beads of caulking or gaskets or something along the bottom plate, between the plate and the floor. The foam isn't going to help me there. I still got to picture frame the windows. So spray foam helps with the overall airtightness, but at the levels of airtightness we're going to be looking for, are looking for in houses, it's not the end game. We still have to detail it correctly. And so those are all interior details, and thinking about, could drywall or poly be my air barrier? What trades are involved? What materials do I need? Many then have taken that and said, well, that's too difficult to do from the inside. Why don't we switch to the outside? And the answer is, of course, things like sheet membranes, water resistant barriers, things like insulated sheathing products. These are intuitive air barriers. The product on the right, a coated sheathing product, these are all okay. I'll say better than okay. These are intuitive air barriers that you can be really successful with, as long as, again, compatible tapes, compatible caulkings, and then still the question, whose job is it? Clearly, these are going to be in the framer's bailiwick. So now the framers have to become air barrier experts, and you're going to have to give them the proper materials. For example, the one in the middle there, the foam. We need to understand that foam expands and contracts a little bit, so that we need to think about a tape that will expand and contract. So as long as we're using the right tapes, we're good to go, but making sure the framers have access to that at the right time. But even in the middle there, that same picture, or even the one on the right, what happens with the roof to wall intersection? I need to make sure behind those roof sections, I've got continuity of that air barrier. And what does that do to the air barrier? So and mechanical contractors and electricians and plumbers all putting penetration through. So the story I'm trying to build here is you choose your primary air barrier. These are all great materials, all great choices. Pick one of them. Now it's about the detailing. How do I get to the level of air tightness that I really need for my buildings to be successful? And just, again, a little pieces or little pictures of that, just to say, how do I get that detailing through those shed roofs, the gable ends, through the cantilevers, the overhangs? How do I get those done? And what's the approved methodology to the windows themselves? How do I air seal those? And what is the compatible tape or caulk between the windows and the sheathing product, for example, is vitally important. And so I'm just highlighting that again, the idea of these difficult locations underneath that gable, that little shed roof on the right-hand side, that continuity of that air barrier. Who's going to do that? How do I do that framing? Is that bolted on after the fact because the air barrier had to be continuous? Or do I run material down through as I'm framing that roof section, as an example? So these are all details of exterior air barriers. And if we think about, let's say, a membrane product, what are the compatible details? So Tyvek, for example, down in the bottom right has this product called Easy Wrap, which really nice flexible product that would allow you to go around plumbing penetrations. A great CI partner is Quick Flash, and their product looking for those small penetrations. And again, whose scope of work is this in? Do I hand the plumber a roll of the tapes? Do I hand the mechanical contractor some of the Quick Flash? Trying to find a way to involve the trades, because all of them have to be part of this conversation. Just again, more detailing. One of the points I like to make, this is a multifamily project, and I want to remind you, Paul, you talked about changes over the last 10 years, but go back a little further. 30 years ago, not one of these vents would have been in these walls. People didn't have individual dryers and individual suites. They didn't have range hoods. They didn't have bathroom fans. They were all done centrally in multifamily buildings, and the penetrations went through the roof. And the roof all had flashing and counter flashing details. Now all these penetrations to meet the expectations of today's consumer. I don't have one penetration on the roof for all of the dryer exhaust. I now have, in this particular location, 186 dryer vents, 186 bath fans, 186 range hoods, not to mention air conditioning line sets, so on and so on. So we have to think about the change in the complexity of the way houses are built, buildings are built, and the expectations of our clients for air tightness. And then, in fact, just click through a couple of slides. There are a couple of clicks, if you wouldn't mind. Thinking about the multifamily on the outside, what about multifamily on the inside? We know that complaints of noise and odors are an issue in multifamily buildings. So we have to think about compartmentalizing both inside and outside. And now, so how do I treat those walls? Am I back to an interior air barrier like drywall, or am I going to use a sheet good or a foam product in order to make them airtight? So sealing all the penetrations, you can go ahead and click another couple if you wouldn't mind, Travis. I think we'll one or two. And so sealing all of those penetrations, exterior and so on, getting to that level of air tightness, not just the whole building, but indeed all of the interstitial spaces as well. Go ahead and click. Thank you. And so we think about compartmentalizing. In this case, these are platform or sorry, poured concrete floors. Okay, so the concrete itself is tight between floors. What if I'm doing wood framing on the right-hand side? How do I make that continuity of those floor joist systems? So on the left, it's pretty straightforward. In this case, a steel framed wall. I'm going to make drywall my air barrier. I'm going to put beads of caulking so it's airtight to the concrete on the left. On the right, we're seeing products like these shaft liners. And you'd say, well, that gypsum's airtight. Absolutely, the gypsum itself is airtight. But what about the H channels that it goes into? And we found surprising leakage. I was kind of disappointed. I thought, wow, this is going to do it. And it's just inherited the system. It's not a bad product. It's just they haven't necessarily thought about airtightness in those particular locations. And again, these are all hundreds of lineal feet of joints and crevices and cracks that we need to think about. We need to find a simpler way to air seal those products or those systems. And, there's various strategies. The one on the left is using a wrap product between the floor joist cavities. The one on the right, again, using that sill gasket material to create the air barrier between dwelling units. So these become challenges, and you're already drywalling. Drywall's a good air barrier. How do I make that continuous through those elements is the important part. And of course, now we want to come to this new air barrier technologies. Some of you have seen the fluid applied products that are put on the outside of buildings. So if you have a standard house, let's say a 3,000 square foot house, there might be, 3,000, 4,000 square feet of wall on the outside. So or gypsum sheathing, could I just coat it with a monolithic coating? And that's fine, but you're talking about another 3,000 to 4,000 square feet of material. At what thickness? At what temperature? What about compatibility of materials? So I'm a huge fan of the spray applied products, fluid applied air barriers and weather barriers. These are better suited as, I would say, water resistant barriers. I'm not sure they give you the rigor that you want from an air tightness. And Paul, what's really cool is you're working with a company that developed, well, eons ago, a product that was targeted and not having to cover existing materials. Let me say it one more time. If you have OSB on the outside of your house and it's your primary air barrier, now you're going to coat it with another material at the right thickness. Boy, I'm adding a lot of material, extra material. Whereas on the right-hand side, Paul, we're going to be talking about a process that simply looks at finding the holes between the elements of your primary air barrier. Let me say that one more time before I bring you back in. Drywall 4x8 sheets are airtight, but on those edges of those 4x8 sheets, that's what I need to think about. Same with OSB. You're going to say, well, I tape the joints of the OSB. Great. So I don't need to worry about those. But what about the edges of that drywall as it meets the floor plate, for example? And AeroBarrier is going to find those leakage spots. But it wouldn't be a bad idea just at this point, Paul, for you just give a little history of how did you guys come up with this idea? Where did this start?
Sure. Yeah, and if I could just take a minute and hit on a couple of things that you've talked about. When you think about the construction of homes today, 10, 15 years ago, we were building boxes, right? Consumers, builders have started to change that dynamic. There's custom kickouts, there's custom details, there's knee walls. There's all these special details in homes now that it's not as straightforward of where you have to air seal and what products go where, right? So that's one challenge we have to adjust for. And on top of that, to go back to the multifamily piece of that, when you think of the exterior air barrier, right, that Gord's been talking about, that is a really good product when installed well. But unfortunately, the party wall gets no benefit as far as air sealing from the exterior air barrier, right? So there has to be special details taken into account when looking at the party wall in particular, because that's something that's not typically focused on the single family side of construction that is new and nuanced to multifamily that you need to be really mindful of and take special care to air seal properly. So as Gord mentioned,
Paul, I wouldn't mind just asking a little bit more on that, or at least delving into that. I really appreciate that. Number of corners in a house. People say to me, well, there's 4 corners in a house. When was the last time any builder on this call built a house with 4 corners? I was at one the other day, 63 corners in the house. And so that's a challenge. But to your point, not only you have an exterior barrier in multifamily and you have a the party walls, but they actually have to connect, right? That continuity of the air barrier, the interior side has to connect with the exterior. So thank you for that. I just wanted to highlight that. That's a great comment. But yes, by all means, give us just a little bit of the history. I'll click one slide, and that maybe help cue you up here. Oh, sorry. Oh, that may have been in the wrong spot. Oh, my apologies. So let's go back one, Travis. My apologies. I may have one slide out of place. My apologies. But Paul, give us a little sense of where the process started.
Sure. So our company's been around for over 25 years now. We started as AeroSeal, which you may be familiar with. That is our duct sealing solution. It started in California through some grants through the DOE and Lawrence Berkeley National Lab. Since then, we've taken that technology and sealed not only hundreds of thousands of houses, but tons of commercial buildings. Most of the hotels you see on the Vegas Strip have been sealed with AeroSeal as far as their duct system and ventilation systems. With that, over the last, call it 10 years, we've taken that same general principle and how that solution worked, and we've adapted it to the house, right? So the way we seal ducts is we put positive pressure on them. It self-identifies the leaks, and we inject a sealant that allows it to seal all those leaks. We've taken those same general principles and we've just applied it to a new application, and that is AeroBarrier, where we can apply it to the whole house, driving efficiencies and making a builder able to dial in the performance that they're looking for, whatever that target is.
And thank you. And if we went back to the slides, what I wanted to highlight, so go ahead and click that slide if you wouldn't mind, Travis. And when you think about it, it's really about meeting those new goals, right, Paul, of understanding that people want healthy, safe, durable, comfortable, efficient. So in the same way that you talked about the complexity of houses increasing, the complexity of people's expectations, I think, is really important. And we're going to see that in a code context as well. And that's why AeroBarrier is kind of a nice technology to bring that to it. And we'll have a chance to just go into it deeper here just in a second. But just want to go back to a few of those and mention to you, many on this call will already be doing air tightness testing of their buildings. Why is that? Because 28, I think it's 28 now, it's probably 30 now, U.S. states now require blower door testing of all buildings, air duct sealing or duct testing and air barrier testing. And why, we would say, why is that? Partly from an energy perspective, partly because of chances are of problems for condensation within wall cavities, which we'll come to. So it's now a code requirement in many states. And I would say to you, that's good news. Remember I said homeowners are worried about that word continuous and sealed? Now that you have this objective measure, you can say, I met code requirements. Rather than subjective measures of continuous or sealed, now you have an objective measure of the actual air tightness of that building. And so we're starting to see that throughout the country, and you guys will at least should have a sense of, most on the call, that houses are tested to one of two levels. Southern zones, that is, let's call it southern Florida and southern Texas, climate zones 1 and 2, at 5 air change per hour at 50 pascals. So those who aren't familiar, big blower door, big fan in the front door of the house, creating a negative pressure of 50 pascals. What's that? Roughly 25-mile-an-hour wind on all sides of the house at one time. And under that exaggerated condition, leaking no more than 5 times an hour. That sounds like a lot. It is a lot, and we'd like to be much tighter than that, but it's an exaggerated condition. It's not the way houses leak on any given day. In northern climates, let's call it mid to northern climates, 3 air changes per hour. And we would say to you, these are minimums. And ask yourself, why is that in the code? And although it's in the energy section of the code, it was actually first put in the code to make sure there was no warm, moist air leaking into cold cavities. I'll come to that in just a second. It wasn't originally put in the code for energy. It was put in for building durability. So we can go ahead and click the next slide. Thank you. So, and go ahead, click through to the, there's a couple of comments on there. Thank you. And when we think about air tightness, is it good or bad? And we always say, what have we learned? What do we know? We know that air tightness is important from an energy perspective, from an interstitial moisture perspective. But we do have people who are worried about, let's say, air quality, houses being too tight, which is probably a subject of another webinar we've done with CI many times. I will say this to you. You've had ventilation in your code longer than you've had air tightness in your code. You've always been required to ventilate your buildings, and more recently, you've been required to air seal or make your buildings more airtight. So the air quality side was thought of first. It's already done. You can go ahead and click.
If Gord, if I can add real quick, that's one of the
Yep.
questions that we get quite a bit. You know, your building's too tight. Why are you making them so tight? And we 100% agree with the idea that buildings need to breathe, but you want to control it, right? You don't want it coming through the walls. You don't want it coming through your attic and your insulation. The HVAC system is the lungs of your home. That should control the ventilation and the air that's coming in. And we want to seal the house as tight as we can and let the ventilation system control and make that a healthy home. Because if it's leaking and you aren't controlling that leakage, it's bringing in whatever's in your attic, whatever's in your wall system, dust and pollutants from outside. So we 100% agree the houses need to breathe. That is never an argument that we're going to go against you on. We just want to control how it breathes and, you know, be in control of where that leakage is coming from.
And Paul, you will know that I'm being older than you. I can tell you, we used to ventilate our houses with windows. We never got fresh air through electrical outlets or through the logs. We got our fresh air by opening windows. Why? Because we had control of it, right? We could open and close. Mom used to come in and say, I'll open your window an inch, dear. I'll open your brother's window an inch. That'll get you some ventilation. Of course, it was controlled, but still only controlled by, I would say, Mother Nature. Now we've moved towards mechanical ventilation, as you noted. So we've always had houses breathing or ventilated. What we want is no uncontrolled holes in walls or attics. So thank you for that. That's a really good confirmation. Remember, we've always ventilated by windows and now mechanical systems. So we can go ahead and click that next slide. I just want to do a little bit of the why, as we've been alluding to. And thinking about the building science rules. And what we need to know is number 4 in that screen, air in equals air out. Wherever air is coming in, somewhere in the equal amount is leaving that building. The reason I mention this is because we thought we could make houses just tight enough, so we wouldn't need mechanical ventilation. And what we learned was that's really difficult to do, because I need 2 holes, opposite holes, if you will, and those holes had to change locations summer to winter because of warm, moist air rising, stack effect, and so on. So the building science rules really led us to the fact that we need to make buildings more airtight. So go ahead and click again. Thank you. And the reason we need to make buildings more airtight is because we started adding insulation. You're going to go, what? As we added insulation, we stopped the drying potential of buildings. Heat moved through our walls. Heat made our walls dry, our attics dry. Now, when we add insulation, that's stopping the flow of heat. We don't have the same drying potential that we used to have. And our building materials on the outside of our buildings have gotten colder, so more chance of condensation. We've also started to use building materials that are more susceptible or sensitive to water. I love OSB. Obviously, it's a great product, strength to weight ratio, its dimensional stability, and so on. But I think we all agree it's more sensitive to water, so we have to do a better job of keeping water out. And it turns out that air leakage is a major moisture flow mechanism as well. So we'll just delve into that as quickly as we can so we can get on to the AeroBarrier technology. And what's really changed, this moisture in this attic is not because of lack of ventilation in the attic. The problem here is we've got warm, moist air leaking through a fibrous insulation, and the insulation made the roof sheathing colder, right? We added more insulation, the roof sheathing got colder, and therefore we have warm, moist air contacting cold surfaces. The way to solve this is by making houses more airtight. So we just need to keep that in mind, that the derivation of air barriers was indeed, and go ahead and click that. We can play the animation if you wouldn't mind, Travis. So when I take warm, moist air from a house and pass it through the wall, for example, and it goes through the insulation, it starts losing temperature. And when it loses temperature, it may reach the dew point, and you will get condensation inside of those cavities. And you have 2 ways of solving that. 1, stop the warm, moist air from getting in the wall in the first place, make it airtight, or 2, put insulated sheathing on the outside. That is, add insulation. Both of these are great strategies. We would say, let's start with the option on the right. Let's make sure that no warm. Then when I do add insulation, add it to the outside of the building. Rather than making your wall, the cavity thicker, make in fact the insulation on the outside thicker. So that's kind of the building science approach to solving this issue of condensation within wall cavities. Make it airtight. And the more you insulate a building, the more airtight it needs to be. And that's a key factor, a key element that we want to talk about. And there it is in, I would say, in the graphic form, or at least in the physics form, that as little as 1 square inch of leakage can put as much as 14 liters of, 14 pints, there's the Canadian in me, 14 pints of water into a wall cavity over the course of a 2-week period. So air leakage is a major moisture movement mechanism. We need to solve this because we're adding more insulation to walls. And we've had this conversation for years. The vapor diffusion, people talk about we want the walls to breathe. That when they're talking breathe, they're talking about vapor diffusion. It turns out that very little water vapor moves through walls or attics by vapor diffusion. Most of the movement is in fact by air leakage. So it's really important to make walls airtight, attics airtight. Worry less about vapor diffusion. It's not that big a deal. Go ahead and click. And I want to then superimpose on you, that's a code difference, but what's the expectations of today's consumers? This happens to be my son and daughter-in-law and grandson. And I think you would say, when I said to him, Andrew, you should really get your house blower door tested. He said, why? I said, to find any of the holes. He goes, holes? Why would there be holes? His expectation is 0 holes. And he would say to you, why? He doesn't want the dust coming in. He doesn't want smoke coming in or bugs coming in. He doesn't want the cold drafts. He doesn't want to pay the energy bills. He doesn't want that water getting into his walls. And he knows that it adds to the cost of operation. So indeed, consumers actually get this. They don't want holes in their walls. I'll just restate that again on this next slide and ask you, I'll challenge you to ask any one of your customers exactly how many holes would you like me to leave in the walls or attics of your house? And of course, they're going to say none because they don't want to be wasting energy. But to Paul's point, when would they want fresh air in their home? And the answer is all the time. So how do we juggle those two? How do we help people understand that no holes in your walls or attics, but we still want houses to be ventilated? Paul, you used the word breathe. That's either windows or mechanical ventilation. And the good news is all houses now in North America have both. All houses have more windows than ever before, and all houses have mechanical ventilation, whether that be a bath fan, a range hood, or ERVs and HRVs. So we actually are able to say to clients, you get the best of both worlds. You get the no holes in your walls or attics, but you also get better fresh air, better control over your fresh air. So that's an important element of this. And then I mentioned to you that it's a big portion of the energy cost of a house. Notice in each one of these pie charts, in terms of heat loss, winter heat loss of a house, and I don't care where you are in the wintertime, you are always at least 30% until you work with AeroBarrier. You're at 30% of your winter heat loss is associated with air leakage. And even in a HERS 50 house, it's still 15 to 20%. So we can always do better from an energy perspective. It's the single most cost-effective thing you can do to improve energy performance, both summer and winter, is by making your building enclosures more airtight. So there's an energy component, there's a moisture component, there's an energy component. Here's another moisture component, because people will say, well, in the South, we don't have to worry about that heat loss. But this is in Florida and in Houston. Air leakage in the summertime can bring in as many as 20 to 40 pints per day of moisture into your house. So we all know you're having moisture, there's high relative humidity issues in Florida, in Nashville, in Texas, not in Phoenix, of course, too dry, but in those hot, humid climates. And people say, well, we're building them too tight. No, you're not building them tight enough. Air leakage via wind, via mechanical effects, you're actually bringing in a lot of moisture and a risk of condensation. We see it in dryers, for example, moisture accumulating in dryers. We see it on bathroom fan housings, the metal housings. We see it dripping from can lights in the ceiling because that relative humidity hitting cold surfaces. So if you want to maintain proper humidity levels in houses, you want to make your buildings more airtight. Hopefully you're seeing this connection is with respect to this. Yes, go ahead. Keep going. One more slide. One more click. Thank you. And go ahead and click those. Yes. Thank you. Just keep clicking to the end of that particular element. So how tight do we want to be? I'm saying to you, code is 5 air changes and 3 in the north. The Canadian code more or less is 3. The Energy Stove program is 2.5. The old historic R2000 program in Canada, the tightest houses built in the 80s, were 1.5. I think you can go one more, please, Travis. Hopefully there. The passive host program, the Germans would say, oh, go back one, sorry. You cannot go back and click through those. Yes, sorry. The reason I want to show this, sorry. Technology. Thank you for that. Passive house 0.6, and you're going to say those Germans, why do they want that so tight? It's okay, leave it there. Why do they want it at 0.6? Here's why. It's because they want extreme amounts of insulation in their walls. They want R40, R50 in walls, R75 in attics. And the more insulation you put in your building, the tighter it needs to be in order to avoid condensation. They also look at it and go, well, we only build a house once. Let's go ahead and make it tight right to begin with. What I want to say, and Paul, you're going to help me with this just in a few slides, can we get down to those levels of air tightness using AeroBarrier? That is, many builders on this call will say, been there, done that, I'm at 5, or maybe I'm at 3, but in fact, do we want to get lower? And I'm going to say to you, as time moves by, we're going to want them even tighter because we're going to be adding more insulation, and there's going to be a drive towards our whole climate change initiatives. So these concepts of air tightness, go ahead and click the next slide. These concepts of air tightness are sometimes hard to visualize, so we often use the phrase equivalent leakage area in the house and put them into one hole. How big would that hole be? The one on the left you're seeing is an open window. That's like 5 air changes. 5 to 7 air changes per hour is a fully open window. The one on the right is a single pane in that window. That's down around that 1.5 air changes, maybe 2 air changes. So looking at that equivalent leakage area, I have a slightly different way, if you just click that slide, slightly different way of looking at that for you. This is more or less to scale. The blue square, it represents the 3,000 square feet, the surface area of a 3,000 square foot house. And you would say, so how big is the hole in that house? The top left, look at that little dot. That's the difference, the size of hole that you would have to seal in AeroBarrier's world, the amount of sealant that you would have to put in the house to get the house from 3 air changes down to, say, 1 air change. In other words, what you need to know on this call is what we're talking about is very small amounts of leakage. And you go, are they important? Yes, you just saw. They let in moisture. They cause noise and dust issues and odor issues. They cost huge on your energy bills with respect to 30% of the energy of your houses. This small amount of leakage, and you can start to imagine the thousands of square feet of drywall or WRB or foam sheathing or spray foam that you're using. That's your primary air barrier. Now what we want to get at is these smaller holes. How do we get the small holes? Let me say it one way slightly differently. You did a nice job over the last 10 years of getting from 9 air changes to 7, from 7 down to 5, from 5 down to 3. And now we're saying to you, you need to go even further. 1, because you're going to be adding more insulation. 2, because interstitial condensation is going to be a bigger issue. 3, the demands of your homeowners are going to be, I don't want the draft, the noise. And 4, moisture control in the southern climates with respect to humidity control. So that's where we're really talking about when we talk about AeroBarrier, is the ability to get at these really small holes. So go ahead and click the next slide. And so, Paul, let's walk through the process. You talked about who AeroBarrier is, what they do. I'll just read a little bit here and just say, this consistently tighter building envelopes, the verified documented results, and in a single process in a time saving. But walk us through, if you wouldn't mind, if we click that slide, walk us through the system and just describe to us what we're seeing here, and then we'll move through the process.
Yeah, so what's on the screen there is our AeroBarrier Connect system. It's a modular system that takes the guesswork out of air sealing. So you see the big fan on the right side. Instead of using a standard blower door fan, we use a little bit bigger fan because we need a little bit different pressure, or we have a little bit different pressure requirements. So that fan pressurizes the house and allows us to seal the leaks that are in the structure. The orange box you see in the middle is the brains of the system. That actually creates a wireless mesh network connecting to all the different sealing stations in the laptop and really controls the process from start to finish. This system's controlling temperature, humidity, amount of sealant being injected, the amount of pressure being put on the space, and it's all really being controlled by that hub there in the middle. The one on the left is our smart sealing stations. These are essentially the stations that are atomizing the sealant into the air. They all have temperature and humidity sensors built into them, so they adjust based on the ambient temperature around them and can ramp up or ramp down the amount of sealant being injected at any given time. And like I said, everything's being controlled by the laptop. So as long as the technicians are paying attention to what the laptop is saying and executing on those commands, the system controls the process from start to finish.
I think we have a few slides. There we go.
Yeah.
So step one is we're preparing the house for sealing. You're covering all the large openings, the intentional openings where air needs to go through when the house is finished. So we seal those off. Paul, in our experience, that's 45 minutes to an hour. Is that what you're hearing across the country?
Yeah, obviously based on the size of the house, but we typically budget about 45 minutes of time to get the house ready to be sealed. And to your point, Gord, the biggest piece of this part of the process is what are the designed openings, right? What needs to be protected and remained open, and what do we need to protect, right? The one thing outside of designed openings that we always need to protect is any finished horizontal surface. So you'll see in the top left picture there, they're covering the windowsill. Now, that's not because air is going to leak through the windowsill and we're concerned with it sealing it. It's more for after the process and cleanup. The sealant particles are going to fall on the horizontals, and if there's any finished horizontals that will be there when the homeowner takes occupancy of the house, we just want to protect it so the cleanup's much easier.
Thank you for that. And next slide. So then we're setting up the blower door. So very similar in process, except now we're pressurizing the house and deploying those modules throughout the nozzles throughout the house. The way I often characterize this, Paul, back in my early days of blower door testing, I would come to a house, set up the blower door, and then myself, the builder, and his handyman, and maybe a couple other trades would each fan out around the house with a smoke pencil and a foam gun and a caulking gun, and we would try to seal up. And it was done just after drywall, and we hoped to find the seals, and then we would hope that we would see a change in the blower door. I'd keep running back to the blower door and modulating the pressure to see where it goes. In this process, basically, you have a bunch of robots. They're called nozzles or modules, sealing stations that you're deploying around the house to do the work for them. Have I characterized that correctly?
Yeah, pretty well. It's a self-identifying, self-sealing system that identifies all the leaks in the structure and seals them at the same time. So you can see in the pictures here, as Gord mentioned, we'll put our sealing stations all throughout the house in kind of a uniform manner. Those sealing stations, we can put as little as 2 sealing stations and as many as 8 into a house, depending on the size and layout of the structure. Once those sealing stations are in place, the MCU will activate the sealing stations and they'll start to spray or atomize our sealant throughout the air. Now, as Gord mentioned, we are putting this under positive pressure where a standard blower door test would be negative. So we put 100 pascals of positive pressure onto the structure. At that point, air is finding all the leaks and cracks and crevices in the structure and finding its way out of that high pressure environment. Once that happens, we'll start to atomize our sealant, and the sealant is designed to float or stay suspended in air at pressure. So at that pressure, our sealant particles are floating and staying suspended, and at the point, air becomes our method of transport. Air is leaving through the leaks in the structure and identifying those leaks. The sealant is carried to those leaks through the air, and as they reach that leakage point, they just start to collect on the leak until that leak is completely sealed. So like Gord mentioned, it's a really effective process. It identifies the leaks, it seals the leaks. There's no wasted material. You don't have to guess where a leak is anymore. The sealant is going to be drawn to the leaks in the structure, and it's going to go ahead and seal those leaks as it exits the structure.
And again, the way I see it, it's a crew of 2. You got that flurry of activity, 45 minutes, and then you sit back, eat pizza. My son, I always give him a hard time. I call him around 11 o'clock, eating pizza yet? Because he's waiting for this product to do its work. And you think about the number of man hours, the number of trades. Remember, we talked about the trades, the electricians, the plumbers, so on, all with rolls of tape or beads of caulking or cans of caulking. And now you're saying, let's find those leaks on our own. So we'll just go to the next slide. Oh, sorry, I can keep going, sorry. My apologies, I had an extra slide in. Thank you. And as you said, Paul, it's all being controlled. What I think is most fascinating, we love doing demos for builders because they can see real time on the screen. Obviously, you're not in the house while this is being done, but you're outside and you're watching the screen and following. And what we find is builders say, well, just get it to 2 air changes. And we get it to 2 air changes. Well, let's go to 1.5. Well, let's go down to 1. Let's see how low we can go. It's kind of an interesting concept when you see the parameters on the screen to see what's happening. It's kind of cool. I don't know if you wanted to make a comment over that or not.
Yeah, I mean, this is really the power of the system, right? This laptop and this software is controlling the whole process from start to finish. Once our techs get the system set up in a position to be successful, the software really does most of the heavy lifting after that. It's measuring temperature, humidity, the amount of sealant being injected, the pressure being being put on the house, but most importantly, every 60 seconds, this system is getting a blower door reading. So as Gord mentioned, in real time, we can give you your results and dial in that performance to whatever performance requirement you're looking for. If you're just looking to hit 3 ACH 50, that's fine. We'll dial in that system and we'll hit 3 ACH 50 and we'll turn the system off. No wasted time, no wasted labor, no wasted material. But also the beauty of it is we can just continue to run the system. And, we have production builders doing 200 and 225 homes a year that take their houses to 0.2 ACH 50. And throughout the whole process, they're going to see where they started and where they are along the entire process of the seal until they reach the target that they're looking for.
Let's go to the next slide. And there is that software on the right-hand side. You see the graph, that the output of that. I just find that so powerful. Somebody's going to say, well, does that replace the need for a blower door test, let's say, to meet my code requirements? And the answer is typically no, at least not at this time. I think in future you could say we're going to get enough confidence, but typically the energy rater is still going to come back and verify the test. And the number is going to be slightly different. Remember, we're going to take off the tapes that were on the window sashes. We're going to take off the tape that was sealing off, say, the bathroom fan. And some of those items have air leakage shield. So the number is going to change a little bit. Doesn't mean AeroBarrier didn't work. It just means that they were doing what I like to call an envelope seal as opposed to an as-built seal. So that software gives you that premise. What's also interesting is it's monitoring the amount of sealant you used. Paul, that's great statistically for you as a company to look at the various parameters. And we've seen really nice improvement just over time in terms of process by feeding back the information and saying, in this climate zone at this temperatures, let's adjust the way we do that seal.
Yep.
Good. And I'll just go to the next slide. I think it's the key to me is that, and we'll just stay off it, or we can go off it quickly, but the idea of this verified results, I think, is so powerful. I'll just say this again. For 30 years, I've been driving up to a site with the big red door. The builder's nervous. Every builder I've ever met wants to do good work. Nobody likes to fail a test. And they're always nervous. For 30 years, they've been nervous. I was just with Tom Cochran here in Canada, one of the best builders in my mind in the country. He's not failed a test in 30 years. And yet he's still nervous when I come to the door and I say, Tom, isn't it going to be nice? You don't need to be nervous anymore. Then he goes, yeah, that'll be kind of cool. And so the idea that we just takes away the angst, takes away the labor, takes away the angst. We'll go to the next slide. Just a few slides left, folks. Just give you a little sense of the results. Showing the seal results is probably better. Well, you'll see here, I think I said 5/8 of an inch, but around an electrical outlet, around plumbing fixtures and so on, you start to see that, you said it nicely, Paul, just kind of accumulates around the hole, magically accumulates around the hole. And it looks like a gray caulking, right? I have a piece of it that I've had in my car for 3 years now, and it's still flexible, still pliable. It feels just like a latex caulking to me that stayed flexible. It's a little gray in color. Go to the next slide. I think it gives a little better close-up of what that looks like. There it is, around an electrical outlet. That's that sealant, that caulking. The question we always get, Paul, is it compatible? How long does it last? You guys have done the testing, but so give us just 30 seconds of the rigor of the material.
Sure. So yeah, we've done all kinds of testing in the lab and in the field for the material. And the standard lab test is a 50-year aging test. We did that test and really passed with flying colors. When we started that process, the the seal was 99.9% effective, right? What you would expect from a brand new seal. When we were done with that test, the seal was 99.87% effective. So very little seal degradation. And I'll give it to you, it was in the lab. So perfect environment, perfect conditions. But we've also done this with builders. And some of the builders, when we first started this process, have been gracious enough to allow us to come back to houses and do blower door testing. In one of the first houses we ever did, we sealed it to 0.6 ACH50 at the final blower door test. And we went back a little before COVID. We were out in Arizona with that builder, and we ran that test again. And that house is now at 0.7 ACH50. So very little change. And if you know anything about a blower door, that's obviously within the range of error of a blower door test, especially with that little leakage. So we feel really confident about the sealant and its durability, and it's not going to become brittle and crack out. It's not going to cause issues down the road. It will stay durable, flexible, and pliable for the life of the sealant as it's put in the built environment. The one thing I will call out, that if you look at this picture, and a question we get all the time, well, what about the drywall, right? What about other surfaces? So there's a couple different points in the construction process we can apply the technology. Now in the South, conditioned attics are a little more prevalent. If you have a conditioned attic solution or build, we can apply it rough in, and we'll go either before your fibrous insulation is in place or right after spray foam. Now, if we're going after, or if you have a vented attic, we're going to go after the lid is in place. So after the first coat of drywall mud is the most typical application. Now, if you were to walk into one of our projects after we were done applying, you could rub the drywall and you'd never know we were there. Right? It's not going to create this film or mess over everything. The sealant only collects where there's leakage in the structure. So there's no additional cleanup or wipe down required of drywall or vertical surfaces because the technology created a mess over everything. It just doesn't happen. The sealant only collects where there's leakages in the space, and there's no additional cleanup on vertical surfaces other than or outside of that.
Thank you. And we're a little bit into the rapid round here. I think we said we'd be done at 15 after the hour. So just again, I'll recap for you the benefits of AeroBarrier. If you could click the next slide. So yes. Oh, sorry. Click again. My apologies. Paul just answered that one, when to apply. In terms of the benefits, then it's you get some trade-offs out of this. That is, you get to optimize the performance. If you've got better air tightness, and you'd say, well, is there something I can reduce? Well, we spend a lot of time on this with builders. We would say always, of course, add more insulation, but perhaps you can use a different type of insulation and simplify your process that way. Two, this is shorter, more consistent build cycles. You know, we see this specifically in programs like Passive House, where they're trying to get down to 0.6. They might leave 3 weeks in their schedule to get it down to 0.6 late in the process. And we can do this literally in half a day to a day. So we see shorter cycles. Even for production builders, there's not that angst of failing the blower door test late in the process. This has huge impact on mechanical sizing. Remember I said that air leakage was 30% of the heat loss pie. That means your furnace is sized in accordance with that. If I know I'm airtight, I can say to my mechanical guy, hey, put in a different air tightness number. My furnace gets smaller, my air conditioner gets smaller. And so it also pairs really nicely with whatever air barrier you're using. Let's remind ourselves, this is not the primary air barrier. The primary air barrier is the thousands of square feet of drywall or the thousands of feet of water-resistant barrier. This is a supplement to that to create the continuity, and it's compatible with any one of those. So it allows you to be really effective in those areas. And lastly, of course, that whole impact of the party wall air sealing, which has been really a struggle for builders to get across. Let's go to the next slide. Thank you. This is just a little case study, you know, looking at the air tightness of those party walls, 82% reduction in leakage, you know, 60 units all done in one day, all but two of them under one air change, under that, I would say the goal of 1.5. So really nicely all in one day is pretty cool. Paul, just in the interest of time, unless you really want to pipe in, I'll just go through a few of these, but
Sure.
Okay, go to the next slide. Thank you. There is this labor times saving, and in fact, AeroBarrier went through this, and maybe you should speak to this one, Paul. But looking at what it was taking them to get there, we have our own case study here in Canada. But just speak to this one quickly.
Yeah, so this is a large production builder that was focused on the Energy Star program, 1.5 air changes. So they had an advanced air sealing package that they were doing above and beyond kind of their standard practice. So what we did is we followed their crews around for roughly 6 months, just trying to understand what products they were using, the processes, and the time it took to do it. And you can see the findings there on the bottom left. The additional or advanced air sealing took about 16 hours across 3 separate visits. If you kind of normalize that to $55 an hour, you're at $880 in labor cost. We actually tracked the amount of caulk and tape and foam that was used or bought to do this air sealing, and it was roughly $1,000, a little bit more for the townhouse when you start talking about party wall air sealing. And then we started talking about the site superintendent. You know, as Gord mentioned, when blower doors start to come out, site supers and owners get a little bit antsy and trying to figure out if they're going to pass and what they need to do. I mean, I've been on job sites where a site superintendent will show up with a caulk gun and a can of foam when the blower door shows up, and they just run around the house looking for leakage, trying to pass a blower door test. What's that value? What's that worth? What's that stress and time? If you could get that back, what would that be worth to you? And that's for you to decide. But in general, I think if you click one more time, a number will pop up there. Between $1,500 and $2,500 in savings is what they found just by this advanced air sealing package, quote unquote, to get them to 1.5 air changes per hour.
So they can get to that 1.5, use the AeroBarrier, and eliminate these costs is really the point. Thank you. And
Yep.
Let's go to the next slide. I know we're running short on time. I always talk too much. So. Good. These just a couple examples. Our good friend Gene Myers at Thrive Communities looking to get to that level, better air tightness, and moving from 3 air change down to 1.6. So look at the house, right? Paul, you spoke to the complexity of houses. Wow, this is pretty complex stuff. And if I can guarantee, the number I always have in mind is 1.5. Why? Because that's Harold Orr, the guy who invented the blower door, saying to me, you got to get all houses to 1.5. That's what our goal should be. So Thrive is getting down to those levels. Go ahead in the next slide. This one I believe is really dramatic. It started out at, if I got my numbers wrong, right, at over 9 air changes, and again in relatively short period of time, get it down to that 1.5. Now we would say let's find a better way to get it from. Let's at least figure out some of the other things that we could do to reduce that initial leakage. But so powerful, you can imagine most of that would have been in the party walls because that's where the air leakage is really prevalent in those areas. Go ahead to the next slide. And so in summary, and what gives us a few minutes for questions, I want to say to those on the call, think about the opportunity side of air tightness. As Paul indicated right at the very beginning, we've been doing this a long time. Spray foam, all of those have been really good at trying to get us from, let's say, 9 down to 3. Now we need to think about, can we get even further, and can we take out some of the labor savings? The single biggest problem with the industry right now is prices going up and skilled labor going down. We just don't have access to skilled labor. Let's let the robots do it. Let's let these modules do it for us in that, say, 2 to 3 hour window. That's where I see a huge opportunity for contractors on this call. And it avoids risk. Let's be really clear. The risk of condensation in wall cavities, the risk of comfort complaints, noise complaints, odor complaints, it reduces risk. And you're going to see this to be an integral part of code changes. Knowing that air leakage is such a big portion of the energy bill of a house, you got to attack air tightness. It's the easiest thing for a code official to put in place to say, well, let's just make them tighter because that's better bang for buck than, say, adding insulation to a wall. And we have the skilled labor challenge. This takes away that challenge. I think you're going to find that really fascinating. The technology is available, and it takes away the stress. So I obviously I've said to you I have a vested interest. I'm sold on this concept. I saw the technology, having done blower door testing for 30 years. When I saw AeroBarrier, much like my mentor Harold Orr said, yes, this is where we need to get to. So thank you for the opportunity. Are there any questions in the chat? I know we only have 3 or 4 minutes, but perhaps there's some questions. I don't have access to the chat. Who has access to the chat? Should have asked that, shouldn't I?
So real quick, while we're looking for those, if I could just add a little bit to what you said, Gord, historically, air sealing may not have been that big of a focus or that much focus is put on it. But here as of late, with code changes and certification changes, it's becoming more and more important. Energy Star 3.1 is now requiring 3.0, there are 3 ACH 50 on almost all climate zones. IECC codes are not going backwards. They may be a little bit slower to adopt, but they're going to go forward. So the question is, who's responsible for that? Like Gord's been talking about this whole time, who owns the air sealing? And if you're a contractor on the call or a builder on this call, is this an opportunity for you to reduce the stress, to reduce callbacks, to not fail blower door test, right? There's no other product on the market today that'll guarantee an air change, right? AeroBarrier is willing to do that. Because of the way our technology works and because we get the readings in real time, we can dial in that performance on every structure that we build. So with that being said, with the market in the way that it's going and the requirements that are coming or even already here, is there an opportunity to take air sealing and bring it into the fold or bring it into the scope work that you already have and make it more consistent and make your home more durable, more high performance along the way?
Good thoughts and good finishing thoughts, Paul. Thank you for that. I just got a note that there are no questions. I guess that means we've done a good job. It is a technology, it's kind of interesting. You've shown it at IBS when IBS was in real time, and it won an award for being the innovative product. I still think it's there. I just like I would say the synergies of the building science, knowing that we need houses to be more airtight. I've been preaching it for 35 years, doing blower door tests myself for 30 years. I'm thinking about we need them to be tighter, but always that angst of, I don't know if I can get there. And does it just mean more labor, more caulking, more tapes? One of the things we get from folks is it looks like it's too easy. One building official said to me, it seems like you're cheating. I'm like, no, we're not cheating. You're still putting up the primary barrier that you've always asked for, right? You wanted us to do drywall or poly, whatever it was. We're still doing that. All we're doing is enhancing that. We're not necessarily taking anything away other than the labor to do the physical caulking. Rather than laying down hundreds of lineal feet of caulking, we're going to put the caulking down in places where it's actually needed, where it's leaking. So from a building science perspective, we're thrilled with this product. We think it offers a tremendous solution to a problem that builders have, and all of the stresses and all of their risks of trying to find skilled labor. So thank you very much for this opportunity, folks, for chiming in. And we will have I do see a question there on the screen. Sorry. Oh, this is the classic question. Can this be done on a remodel? And the answer is sure. Here's where I think it really makes sense. If you're doing a major renovation, the flooring materials are out, the cabinets are out. Remember, Paul said you have to cover horizontal surfaces, and you definitely got to cover, all the trinkets and the fluffy toys and so on. So it really makes sense if on either a change of ownership. We just did a very nice case, 12-year-old house, decent built, 3.5, 4 air changes. New owners moving in. We did AeroBarrier, got it under 2 air changes, put in a heat pump as part of that change out, and reduced their heating carbon footprint, if you will, by 58%. So 2 measures alone, 2 measures, air tightness and heat pump. And what was fascinating was they wouldn't have been able to put in the heat pump they wanted to put in because the existing house had too high a heat loss for that heat pump. They would have had to change the ductwork. So yes, it can be done in retrofit or remodel. The problem is the covering of goods. So think about it in major renovation, because you want to minimize the number of horizontal surfaces you want to cover. I'm going to go further. I'm going to say it's the only way to air seal, a deep air seal, an existing home without a major gut. Because we've tried caulking, foaming, weather stripping, electrical outlets, and baseboards. The best we could do was a 25% improvement. We're seeing a 70 to 80% improvement when you use this kind of technology. So thank you for that question. That's a very important one. We get it on every session we do. The short answer is yes. The long answer is logistically think about the amount of coverage you'd need to put on horizontal surfaces. Thank you. Oh, next one. What's the impact on air quality? Paul, you can probably speak to this. I will make it clear. You're not in the house when this is being done. And how long do we have to wait before we're back in?
Yeah, so when you start talking about air quality, after the seal is complete, you need to wait about 30 minutes for the space to kind of settle and for it to be safe for trades to go back into it. So not a lot of downtime. We typically recommend 30 minutes from time of seal completion to reoccupying that space. I would tell you AeroBarrier is an inert sealant. Right? There's no chemical reaction occurring, so there's no off-gassing or any concern long-term about what's going to happen with the chemicals. And it's actually classified as ultra-low VOC, so it's a water-based sealant. Most sealants in the construction industry are solvent-based. Just by the way we apply our technology, we didn't want to atomize solvent, so it is a water-based solution that our sealant is in. So it's inherently a little bit better, but it is ultra-low VOC. It's certified Green Guard Gold certified, which gives it the ability to be used in hospitals, schools, things like that. So inherently, it's a very healthy solution that you don't really have to worry about a lot of the VOC or chemical off-gassing that may occur.
And thanks for that. And you need to remind folks on the call, this is a water-based, you get a 5-gallon bucket to do a house, 2/3 of that is water. It's a mist, a fog that you can physically see. It's relatively big particle size that gets heavy enough that it falls to the ground. It's not lingering in the air. It's falling to the ground and you're sweeping it up and there's really nothing left. The amount of sealant that's left in the house is actually very small. Remember that graphic I showed you with the blue square? That tiny bit of sealant. We're talking about, the equivalent of maybe, a pane of glass is what you're left somewhere in the house, and you've swept it up. Other than that, so it very, very minor. I don't want to dismiss because it's really important to understand. Some homeowners are really chemically sensitive. I get that. So in retrofit, okay, they shouldn't be in the house, obviously, or near the house while you're doing it. Make sure it's cleaned out, scrubbers and so on. But overall, it's a very, very safe material. Not to discount people who have sensitivities. Thank you. What is the largest amount of square footage this can be used for? And the answer is how many nozzles you can actually section off the building. Let's do these 8 rooms. Then let's go over and do these 8 rooms. We did a 25,000 square foot women's shelter, and it did just fine. So it's really just how do I deploy the system?
Yeah, the question is how big of a space can you pressurize, right? It's all based on being able to drive the pressure. So I can tell you we did a 125,000 cubic foot barn here recently. So to go along with your women's shelter, the 22,000 square foot. It can do pretty large spaces, but at the end of the day, if you need to section it off just to be able to pressurize appropriately, that works too.
Good. And I think that's about it. And we're just a little over time. So, Paul, did you want to make any final statement? I'll say my goodbyes, but I'm sure you want to say bye to folks and have them have a sense of, one, I'll encourage people to go to CI, constructioninstruction.com, look for our CI live events. We'll see many of you at the EPA conference next week. Very excited about that. If you haven't signed up for that, it's in person in Denver, and we're having a tour of our facility. But we'd really like to show you our 12,000 square foot classroom and lab. And Paul, you guys are a big partner in that. I really appreciate your efforts there. So thanks for this opportunity.
Yeah, and I can't echo enough. If you haven't downloaded the Construction Instruction app, you should. It is invaluable, the amount of resources that are on that app. If you're on a job site and just need to figure something out, I don't know that there's a better resource that you can instantly find what you're looking for and a solution to whatever problem you may be facing. So if you don't have the app, go download it. You won't be disappointed. And I just really want to say thank you for your time today. Hopefully we were able to give you some information that was valuable and that you can take back with you. If you have additional questions about AeroBarrier or anything that we covered today, please don't hesitate to reach out. You can find various forms on our website, or you can just reach out to us directly. But if you have questions, would like to understand how it might fit into your business or your build cycle, please reach out. We'd be happy to talk to you and work through what that might look like.
Thanks, Paul. Thanks, gang.
Thank
Have
you,
a good
everyone.
day.